In this video, we're going to examine the first part of 1.1 Systems Architecture, which is the purpose of the CPU. The CPU is the component in the computer which carries out program instructions, and it stands for Central Processing Unit. The CPU internally has many components that help it carry out program instructions, such as an ALU, arithmetic logic unit, a control unit, some cache and some registers, which we're going to look at in later videos in more detail. The CPU is really the heart of a computer system. A computer is designed to follow program instructions, carry them out, and display the results in the form of output. So a computer stores programs in something called secondary storage. And this is normally in the form of some large non-volatile storage such as a hard disk drive or a solid state drive. This is designed to hold all the programs and data on a computer, including the operating system, whilst the power is off. When you open a program or you want to execute a program, the contents is copied into main memory or RAM, which can also be known in the exam as primary storage. RAM stands for Random Access Memory, which simply means that data can be placed anywhere in memory and accessed in any order. When a program is called for, it's copied out of the hard drive or the SSD into RAM, because RAM is faster to access than a hard drive or a solid state drive. These instructions, once copied into RAM, sit in what are called memory locations. A location in memory simply has an address in the form of a number. That number helps the CPU to find the instructions it's looking for. It's important to understand that the CPU requests instructions from RAM, and it is not RAM that sends instructions to the CPU unrequested. The CPU has a special register inside it called a program counter, which tells it which is the next address in RAM to call some instructions or some data from. Data travels to and from the CPU down a series of wires or connections called buses. There are 3 buses that a CPU uses to communicate with RAM and other components in the computer, and these are the address bus, the data bus and the control bus, and we'll look at those more later in another video. A CPU operates in a never-ending cycle, and this cycle is called the fetch, decode and execute cycle, and it's fairly self-explanatory in what that's doing. It is fetching instructions from RAM. When they return to the CPU, it is working out what they mean, decoding them, and then execution means to carry those instructions out. And that's all a computer program is. It's a never-ending cycle of the CPU fetching the next instruction, working out what it is, doing that instruction, and then putting the result back in memory. This fetch, decode, execute cycle is really important because the faster it happens, the faster we can execute our program and the faster our computer will run. These cycles are measured in something called hertz, which is a measurement of how often something happens per second. So 1 hertz would mean 1 cycle per second. Modern CPUs are extremely fast, and the number of cycles they can do in 1 second are measured in the billions. The word for this is a gigahertz, and it's written shorthand as GHz. So 1 gigahertz is equal to 1 billion cycles per second. As you can imagine, this means that a CPU is capable of carrying out billions of fetch, decode, execute cycles per second, and therefore it can run programs extremely quickly on a modern machine. However, you should understand that programs are made up of many thousands, if not tens or hundreds of thousands of instructions, and therefore the CPU needs to be able to execute billions of instructions per second in order to give you decent results. So, to summarise quite simply, the CPU stands for Central Processing Unit. It is a component of the computer which fetches instructions from RAM, decodes them and then executes them. These instructions are the programs that we run on our computer. So the CPU is the component which enables programs to be carried out, and therefore is the component that makes the computer work. You should also know that programs are stored in non-volatile storage called a hard drive or SSD when the power is off, and programs are copied to RAM when we want them. So RAM only holds the programs and data that we're currently working on. The speed of the CPU is affected by how many fetch, decode, execute cycles it can do per second, and that's measured in hertz. And modern processors are in the gigahertz range. In other words, they can carry out billions of cycles per second.